Hello and welcome to mathandsciencepower.com. If you like what you see here, please remember to subscribe, comment, rate, and share. Okay, chapter 16, problem number 5 asks, imagine that space invaders could deposit extra electrons in equal amounts on the Earth and on your car. Your car has a mass of 1,050 kilograms. Note that the rubber tires would provide some insulation. How much charge Q would need to be placed on your car, which is the same amount that we will place on the Earth, in order to levitate it, in other words, overcome gravity. And the hint here is that we need to assume that the Earth's charge is spread uniformly so that it acts as if it were located at the Earth's center. And then the distance of separation between the Earth and the car is actually going to be the radius of the Earth. Okay, so let's start out by drawing a picture here. We'll have our car. Okay, and the car has a mass of 1,050 kilograms. And the car is on the surface of the Earth. And then somewhere far below it is the center of the Earth. And the average radius of the Earth, you can look this up in any physics book or Google it, it's roughly 6.371 times 10 to the 6th meters. So this will be close enough for us. So to solve this problem, we're going to need to use Coulomb's law again, which says that the force between two charged particles is equal to K, the proportionality constant, times the charge on the first particle times the charge on the second particle divided by the distance between them squared. So the force that will be necessary to overcome gravity here will be equal to the force due to gravity. So let's remember that force by Newton's second law is equal to mass times acceleration, and in our case acceleration will be g, the gravitational acceleration. So the force here will be 1,050 kilograms, and g will be 9.8 meters per second squared. So let's see what we get. 1050 times 9.8. So we get 10,290. Okay, 10,290, and that will be newtons. So we will plug that in for the force. And let's recall that K in this formula is 9 times 10 to the 9th Newton meters squared per Coulomb squared. So that's what we'll plug in here for K. Now an important part of the problem is that we're going to deposit extra electrons in equal amounts on the Earth and your car. So the charge is going to be the same for your car and the Earth. So in other words, we need to know that Q1 is equal to Q2. So in our equation here, if these are equal, we can just call that Q squared. And then we will divide by the distance squared. So the distance here is the radius of the Earth. And square that. So we need to solve for Q2. So if we multiply both sides by 6.371 times 10 to the 6th, and then divide both sides by 9 times 10 to the 9th, and then we'll need to take the square root of all of that to get Q by itself. So Q will equal the square root. So we're going to start with the force, 10 to 90 newtons. We're going to multiply by this to bring it to the other side. That's squared. and then we'll divide both sides by 9 times 10 to the 9th. Newton meters squared per coulomb squared. Okay, and this will tell us what Q should be. Okay, so we will start with the force, which is 10 to 90. We will multiply by the radius of the Earth, 6.371, with an exponent of 6. And we can't forget to square that radius. And then we'll divide by 9 times 10 to the 9th. So 9 with an exponent of 9. And then we'll hit equals. And then we can't forget the most important part here is to take the square root. Okay, so we get 6,812. And let's take a look at our units here. We have newtons on top and newtons on bottom, so those will cancel. We have meters squared on the top and meters squared on the bottom, so these will cancel. And then we have coulombs in the denominator again of the bigger fraction, so that actually means that this is in the numerator. So coulomb squared is what we're left with, and we took the square root, so that just gives us coulombs. So we would need to add 6,812 coulombs to the car, which is a huge number. And we would also need to add 6,812 coulombs to this Earth. And that will neutralize the force, make the net force be 0, and then the car will be levitatable. On behalf of mathandsciencepower.com, thanks for watching.